Hi, I'm Bruce Kyle. I'm an architect evangelist at Microsoft. I work with software companies in the Pacific Northwest. I'd like to introduce Stuart Solarier. Stuart is a software architect with CheckFree and is a Microsoft Most Valuable Professional.
Hello, I'm Stuart Solarier, and I blog at visualstuart.net. I'm a Microsoft MVP on connected systems, and until now, most of us have been programming in C# 1.0. From that .NET 1.1 era, and even if we've got a newer version of the language, we're still using it as if it were C# 1.0. We're going to take a look at what's new since 2003. What changes the way we program? We're going to focus on the language, not practices, not applicability, not even usefulness. So opportunity for abuse abounds. We're going to do just enough to be dangerous.
Hey, Stuart. What's today's Whirlwind?
Hey, today we move into the C# 3.0, which is part of the .NET 3.5 framework. I used nice big letters to draw attention to that. Let's take a look at a timeline of the releases of the .NET framework and the languages and tools that go with. So way back in January of 2002, when .NET 1.0 was new and fresh, and we got a version of the framework, we got a version of the tools, Visual Studio .NET 2002, and we got C# 1.0. Along about a year and a quarter later, we got an update of the .NET framework, .NET 1.1. We got a new Visual Studio, no update to the language. 2.5 years go by. Finally, towards the end of 2005, we get .NET 2.0 along with a new version of the tools, Visual Studio 2005, and a new version of the language, C# 2.0. Now, about a year later, .NET 3.0 gets released, but .NET 3.0 is all about the Longhorn technologies. That's WCF, WPF, WF, card space. That's not about language features. It's not about a new CLR. So finally, November 2007, .NET 3.5 gets released to manufacturing. And it has a new version of the language and a new version of the tools. So we're going to be talking about C# 3.0 features from here on out. Today we're going to talk about automatically implemented property. So today we're going to talk about automatically implemented properties, type inference, and initializers. Let's start with automatically implemented properties, and I know that's a mouthful, so we also call them auto properties. Now, how many times have you written this? Take a look at this class. It's got two properties, X and Y, and two backing fields. We call them backing fields because they're fields that are marked private. They're only really accessed through the properties cap X and cap Y. Now, the getter and setter on this are just providing access through to that. We write those sorts of things all of the time, and that gets tedious. So why not let the compiler write those for us? And so in C# 3.0, that's exactly what I can do. I just say in the property X has a get method and a set method. Do the default right thing. So the compiler is going to generate a backing field for us. And that backing field doesn't have a name. The compiler gave it a name, but we don't know what that is. And that means that we need to use the property instead to get and set values on it. So if that's the case, how do I create a read-only or a write-only auto property? And I do that using the property accessor visibility feature that we got in C# 2.0. We covered that a couple of sessions ago. And so in this case, I've got a read-only point. I've marked the setter on both X and Y private and created a constructor that gives them initial values. That's cool. Let's move on to type inference. These are implicitly typed local variables, and I'm going to stress the word local. So the question is, when I take a look at that first line, which was so long, in fact, I had to wrap, I'm declaring the type dictionary of int and order twice. Once when I'm newing up an instance, and a second time when I'm declaring the type of the variable on the left-hand side of the assignment. Why do I have to write that out twice? Hello, compiler, can't you figure out the type of the right-hand side and make that be the type of the left-hand side? That's exactly what the new keyword var does. I stress that this is a local variable. I must use it in a local context. There are 4 places that that can happen. Here I've got a representative class called something. Inside of it I've got a method or another. It's only inside of a method of a class that I can use var. So it can't be the type of a field or property. It can't be the return type of a method. When I use it inside of a method, it can occur in 4 places. That's as a local variable declaration, inside of a for each statement, inside of the initialization part of a for loop, and resource acquisition, which is what we do when we use the using statement. So only in those 4 instances can I use it, and it does more than save me some typing. We'll find out in a session or two that there are occasions when I absolutely need to have var. I stress that that is a strongly typed instance at compile time. So I still have IntelliSense, even though I declared it as a var, everything works the same as if I had spelled out the full name of its type. Let's move on to initializers. We've got 2 forms of initializers. Let's start with object initializers first. I want to specify values for fields and properties in one statement. So here I've got my favorite class point that's got a, well, in this case, auto-implemented getter and setter for x and y. And I've also declared 2 constructors for point. One that's a default constructor, and then one that takes an integer for the first value x. I've done that so that I can illustrate my new initializer syntax for objects. So P1 is a point, and inside of curly braces, comma separated, I name the field and I assign it a value. Now, if I have a constructor that sets some values for me, but not all of the ones that I like, I can combine those 2 syntaxes, and so I have a point with a value of 1, so I'm using that second constructor, and separately I'm setting the value of y equal to 2. These syntaxes nest very nicely, so here's a circle class that aggregates a point, we'll call it origin, and a radius, which is another int. And so I can initialize a new circle by initializing the origin, and I'm going to do that with a nested initializer. It's pretty much the syntax that you would create if you wanted to do initialization. Here's that same nested initializer that we saw on the previous screen, and I'm just illustrating that there is something subtle going on here, and that is, if I did this the old way without initializers, I would have to new up an instance of point, give it some values, assign that to circle's origin, and notice that P is then going out of scope. It's not available to be used for anything else. So I'm being very explicit about that when I use my initializer syntax. That's cool. I also have collection initializers. So any collection that implements IEnumerable and has an appropriate add method. I'll talk about what appropriate means in just a sec. So here's list of t out of the generics collections, and it happens to implement IEnumerable. It also has an add method, so I think I'm in business. So I new up a list of type circle. So I new up a list of circles, and I use that same curly brace syntax that I might have used for collections like arrays before, and now I can initialize new members of that collection. So obviously it's calling add on each of the objects that I'm initializing in the inner curly braced syntaxes, the 3 of those right there. So I said I would tell you what it meant for it add method to be appropriate. So if add has multiple arguments, we just use that same curly brace comma separated syntax. So here's dictionary, And dictionary is parameterized by two types, a key type and a value type. It implements IEnumerable, and it has an add method that in this case takes two parameters, a key and a value. When I new up a dictionary of string and circle, I use the curly braces shown in red to to indicate the parameters that I'm passing to the add method. And I can do that multiple times because I have multiple curly braces in red here, adding two different objects to the dictionary collection.
Hey, thanks, Stuart. For more information for software developers, see the US ISV Developer Evangelist blog on MSDN.
Hey, it's been fun. Again, I'm Stuart Solarier, and I blog at visualstuart.net. See you next time.